All right, everybody, welcome to Math with Grace. So today we're going to be working through Pre-Algebra, Book 804, Lessons 6 through 9. Lesson 6 begins on the bottom of page 21, and it's all about solving equations with a squared variable. Sometimes we'll have equations like this, and we want to solve for x. And so solving for an x squared is not what we want. We want just the x, not an x squared. So we have to solve for it. Well, the opposite of a square is the square root. So remember, when we're working through these algebra problems, we're always trying to do the opposite to get x by itself. Well, the opposite of a square is a square root. So that's how we take our answer. We take the square root of both sides, and the square root of x squared is x. Now, in this case, the square root of 17 is not a perfect square, so we just leave it as the square root of 17. In this case over here, the square root of 16 is a perfect square because 4 times 4 is 16, so 4 is the answer. Now, as your book notes, there's actually two solutions to this problem because both 4 squared and the quantity -4 squared equals 16. But in this book, they're only concerned with positive roots. Let's turn the page. Now on page 22, they walk through a general algebra problem, right? 2x squared minus 4 equals 96. Well, the first step, our 4 is being subtracted, so we're going to do the opposite and add a 4 to both sides. Okay, that leaves us with 2x squared equals 200. The 2 is being multiplied by the x squared, so we're going to divide both sides by 2 to get rid of that. That leaves us with x squared equals 100. Now, like I said, we want our x by itself, so we have to do the opposite of a square, which is a square root, and we take the square root of both sides. And that tells us that x equals 10. So this is a really good example of how to work through one of these algebra problems to solve for the answer. The other model or example on that page is the formula for a circle, which is, or the area of a circle, which is area equals pi r squared. And if you have the area, you can solve for the radius because we know that pi equals 3.14. And apparently the area of this circle is 530. And so they're just solving in reverse. 3.14 was being multiplied by r squared, so they divided. Then they took the square root and found out that the radius was 13. Okay, let's do some of these problems. So we're in book 4, lesson 6. We're on page 22 and 23. Problem 1A is done for you, so I'm not going to do it again. But let's look at problem B. Problem B, we're giving x squared equals 36. Well, we want to solve for x. We need to get x by itself. It's a super loner. It doesn't like friends. Here there's 2. It says, all right. So the opposite of a square is the square root. So we are going to take the square root of both sides. That tells us that the square root of x squared is x. And then we have to think, what is the square root of 36? Well, 6 times 6 is 36. So the square root of 36 is 6. All right. A lot of these you should know. Some of them, maybe this one, are going to be new to you. But as we work through these, we'll get more comfortable with our squares. All right. So problem C gives us a squared equals 196. Again, we're going to do the opposite of the square and take the square root. So the square root of a squared is a, and the square root of 196 is 14. Okay, so a equals 14. 14 squared is 196. Let's take a look at problem 2. So problem 2's got a little more complicated. We've got a few more steps to do, but it's nothing we can't handle. For 2a, we've got 2x squared equals 18. Well, 2 is being multiplied by x, so that's our first step. We want to do the opposite and divide both sides by 2. That cancels this 2 out, and we're left with x squared is equal to 18 divided by 2, which is 9. All right. Now we have an x squared. We need to get the x by itself. The opposite of a square is a square root. we take the square root of both sides, and that leaves us with x equal to the square root of 9. What's the square root of 9? Well, 3 times 3 is 9, so the square root of 9 is 3. All right, that's 2a. Let's look at 2b. Here they give us x times x. They're trying to be tricky about it, but x times x is just x squared, right? Plus 8 equals 57. Well, the 8 is being added, so we're going to do the opposite and subtract the 8 from both sides. That leaves us with x squared is equal to 49. All right, x is being squared. We're going to do the opposite and take the square root of both sides. That tells us that x is equal to the square root of 49. Well, if you know your times tables, you know that 7 times 7 is 49. So the square root of 49 is 7. All right, now problem C. Problem C is x squared minus 20 equals 52. Well, first thing we need to do is deal with this minus 20. It's being subtracted. We're going to do the opposite and add 20 to both sides. Okay, it cancels on this side. We're left with x squared is equal to 72. X is being squared, so now we're going to do the opposite and take the square root. And so we have x squared is equal to the square root of 72. Now, the square root of 72 is not a perfect square, right? 8 times 8 is 64. 9 times 9 is 81. 72 falls somewhere in between, so it's not going to be a perfect root. So our answer, oh, and I wrote a square here on accident. Our answer for x equals is just going to be the square root of 72. Now, at some point, we'll learn how to reduce these radicals, but that's not our lesson for today. Our lesson for today is simply solving for x, or the variable, when it's squared. All right, so like we've talked about this lesson, the opposite of something being squared is the square root. So when you see an answer squared, we're going to take the square root, but we want to work through all the rest of the problem too first, so that we're just stuck with just two things: the x squared, or the variable squared, on one side and a constant on the other before we do our square roots. Squaring it at this point would be very messy, or taking the square root of it would be very messy. And that's advanced math anyway, like Algebra 2 math. All right, so work the problem through till you have the variable squared on one side and a constant on the other, then take the square root and get your answer. Great work. Lesson 7 begins on the bottom of page 26, and it's all about finding the surface area of cones. And it says to find the surface area of a cone, we must find the area of the bottom circle plus the area of the curved surface. So on page 27, they've got a cone for you that's kind of deconstructed. Here's what a cone looks like on a page, and here is what it looks like deconstructed. Perhaps you've made something like this before, like party hats, or I don't know, cones. But this is what it looks like if you were to cut out card paper and put it together to make a cone. All right, so here they have it laid flat for you so you can see the different parts. So the area of the bottom circle is just the area of a circle, right? Pi r squared. In this case, the radius of our base is 10 centimeters. So pi times 10 times 10, or pi times 100, tells us that the bottom area is 314 centimeters squared. Okay, the next we need to find the area of the curved side. And here, for the first time, we're going to get this little cursive L, and that's representative of our slant height. Okay, it's this length from the tip of our cone to the base. Now, that will have a lot of use as we move through algebra and geometry. For right now, we just want to know that that's our slant height. And here, if you look at it, okay, it's kind of the shortest distance on the outside of the solid from the vertex to the base, okay? That's what this is considered. So here is our slant height, 20 centimeters. So our formula for this part is the area equals pi radius slant height, okay? So we've got pi 3.14, radius 10 centimeters, slant height 20 centimeters. Multiplying all that together, we get 628 centimeters squared. Then to find the full, we've got the base, we've got the sides, we just add them together to get our final answer, which they forgot to label with our centimeters squared. Okay, so let's look at the problem on this page, and then we'll do the next. There's one more on the next page, and on the next page I'll show you the formula all written out. Here we're breaking it down into parts. The next page we'll just use the straight up formula. Okay, so find the area of the circular bottom. Well, area of a circle is area equals pi r squared. Okay, so for our area, it's going to equal 3.14, right, times the radius squared. Well, our radius is 3 centimeters, so times 3 times 3. All right, so our area is going to equal, pulling out your calculator, 28.26, what's our unit of measure? Centimeters squared. Okay, because we had a centimeter here and a centimeter here, we get our centimeters squared. So that is the first part of our problem, 28.26 centimeters squared. Now, find the area of the curved side of the surface. Well, remember the formula for that was area equals pi r L, or slant height. So our area is going to equal 3.14 times our radius, which is still 3, times our slant height, which is 8. So pulling out your calculator again, we see that this equals, our area equals 75.36 centimeters squared. Okay, centimeters squared. Now, finding the total surface area, we add these together. 0.26 plus 75.36 gives us what? It gives us 103.62. So 103, I got a little crowded here, 0.62 centimeters squared. Okay. So our total surface area was 103 centimeters squared. We found the two parts and we added them together. Now we're going to turn the page and use just the formula. We'll still be finding the two parts and adding them together, but we're going to do it all in one step. So let's turn the page. So on the top of page 28 is another problem. Okay, problem number 4. I have written the formula here for you. Please copy this down, not just on this page, but also copy it onto your page 0 and make sure you label it that it's the surface area of a cone. Okay, it's very important. You don't want to get your surface area formulas mixed up. So we want to find the surface area of the cone. We are going to use this whole entire formula. So surface area is going to equal pi times the radius squared. Well, pi is 3.14 and my radius squared is 2. My radius is 2 times 2. Now I've got it squared. Plus 3.14 for my pi times my radius times my slant height, or the L, which is 5. All right, so let's put this first part into our calculator. We've got 12.56 for the first part, and the second part is 31.4. Now we just need to add those two together. And in doing that, we find that our surface area is equal to 43.96. Don't forget your unit of measure, 43.96 yards squared. Okay, remember when we're dealing with areas, which include surface areas, we're always going to have our unit of measure squared. An area is always your unit of measure squared. Okay, so do not forget to write this down on your page 0 and use this on your quizzes and your tests. I'm not interested in whether or not you can memorize formulas. I want to know that you know how to use a formula. All right, that's it for lesson 7. All right, so lesson 8 is on page 30, and it's my favorite lesson of this week because it's finding square roots on a calculator. And perhaps you have done this on a calculator before, perhaps not. This is the calculator that I have on hand right now, and I don't know, it looks like you can kind of see what I see here. And on my calculator, this is my square root button, okay? Most calculators of this style will have the square root button either on the surface or as one of these sub buttons. See all the little writing here? These are all the little sub buttons. If you need help figuring out your calculator, please let me know and I will be happy to help you. But here is my square root button. So I'm going to push it first. And then you can see that it popped up with the little square root, the radical sign, and a parenthesis. Next, I want to put in my number. Now, you do not have to put the end parenthesis, but you can. You don't have to. You could have just hit equal sign after that. The parentheses are there if you're doing a longer problem. And in more advanced math, you'll be putting more things under here possibly. But for now, that's my number, right? And then I hit equals. And it gives me my answer, which I already knew that the square root of 36 was 6. And for this lesson, really, most of our square roots are going to be things we don't know, like the square root of 72. Remember, that was one of our problems we just did. Well, what is the square root of 72? If we hit equals, we find out the square root of 72 is 8.485298, blah, 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 okay? It goes on and on. But we can solve for an exact answer, well, exact-ish, because we have to round, right? We can solve for a close answer by using our calculator. So that's what they want us to do here. So let's look at these problems. So for lesson 8, we're on page 31, and they want us to find the square roots on our calculator. Let's see, I haven't used, there we go, clear this off. Okay. And if you look at your directions, it's telling us to round these to the nearest thousandth, okay? So we need to follow our directions and round these. Now, like I said, to find the square root of 30, I'm going to push my square root button, which is right here, and I'm going to put in 30 and then hit equals. Well, my square root of 30 is 5.477225575. I don't know, maybe it goes on. Sometimes calculators have the ... that tell you it does. So my answer is 5.47. Now I need to round because to get to my thousandth, this other 7 is in the thousandth place, but I have to round. And I have to round that based on the 2 that's here. Well, because of the 2, it's not going to change anything, right? So it's just a 7. So my answer for 1A is 5.477. Okay? Let's clear that and look at B. Now we have the square root of 2.25. Again, I'm going to push my square root button and put in 2.25. All right? And hit the equal sign. So the square root of 2.25 is 1.5. Okay, that one ends real quick. So there's no, can't get it to the thousandth to round. It just goes to the tenths. Okay, and that's your answer. Let's do the next one. 1C is the square root of 97. And then we hit the equal sign and we get 9.848. But then there's an 8 after that 8. Well, this 8, the second 8 is larger than 5. So it's going to bump this 8 up to a 9. All right. So that's how we round that one to the thousandth place. Let's take a look at number 2. So looking at number 2A, our first problem is the square root of 1,000,000. Well, again, square root button. Let's put in our 1 and then 1, 2, 3, 1, 2, 3. So we've got 6 zeros and we hit equals. So the square root of 1,000 is an actual perfect root, and that is, or square root of 1,000,000, and the answer is 1,000. All right, clear that out. Part B says the square root of 1,001. Well, again, square root button, 1,001, enter. Our answer is 31.638, but there's a 5 after that 8, so that 5 bumps our 8 up to a 9, since we're rounding to the nearest thousandth, okay? Let's clear that and do our final problem, which is the square root of 149. We hit equals, and that tells us it is 12.206.5. That 5 bumps our 6 up to a 7. So it's 12.207. So when they ask you to use a calculator to find the square roots, this is what they are expecting. If it doesn't say use a calculator to find the square root, then I just want an answer, whether this would be the answer, right? Because without the calculator, we don't know exactly what the square root is, okay? So this would be our answer for that problem, unless it tells you to use your calculator, like this one does. If it says use your calculator, then I want decimal answers. If it doesn't say use your calculator, then I only want whole square roots, okay? Good job. Our last lesson for this book actually starts on page 35, but 35 is just words. So I went straight to page 36, and we're talking about circle graphs. So what we're doing is we're taking data, okay, and we're changing it over into an actual circle graph. Pie chart basically is what you could call these. People love pie charts. They like to see the different things lined up next to each other. How much of the pie do they take as they work its way around, okay? Well, there's special steps to follow to create such a interesting pie chart. So let's look at those steps, okay? First step, here's the data that we would have as their cost, okay? So the first step is to add the data for all the categories to find the totals. So they went down here and added their materials, labor, equipment, profit, tax, permits, and got a total of $4,000, okay? $4,000 is the 100% of our pie chart, okay? That's why they wrote 100% here. Now you go one by one and divide the value of each part by the total to find out what percent each part is of the whole. What that means is for materials, they divided 400 divided by 4,000 and got 10%. They divided 1,200 by 4,000 and got 30%. Here, where's that calculator again? Let me pull it back out here. They took 720 and divided it by 4,000 and got 8.18, which is 18%. Okay, they took 985 and divided that by 4,000 and got 0.246 or 25%. Okay, they rounded. Remember, when we have a decimal like this and we want a percent, we move the decimal place 2 places to the right. That gave us our percent, 24.6%, which they rounded to 25%. Then they took the 245 and they divided that by 4,000. And they got 0.06. They moved their decimal 2 places. That told them it was 6%. Okay, then the last one was 450. 450 divided by 4,000, which gave them 0.1125. They moved their decimal 2 places, 11.25, so just rounded it down to 11%. All right, that's how they found their percentages. That was step 2. Step 3 now tells them to multiply each percent by 360 and then round to the nearest whole degree if necessary. So what that means, let me make sure my calculator's on screen here, is they took 10% of 360. Now, that would be 0.1 times 360. That gives me 36 degrees. Now, they wrote them as percentages, but to use a percent in an equation, we need the decimal form, right? So 30% written as a decimal is 0.3, and we're going to take that times 360, and we get 108 degrees. For 18%, that written as a decimal is 0.18. We multiply that by 360, and we got 64.8, which they rounded up to 65 degrees. Okay, this is the amount of space that each of these is taking on the circle. So they went down the list as such. Once they had the degrees for all of these, then they draw a circle and they drew one radius. Doesn't matter where you start. They just drew from the center of the circle out. Okay. And then they took their, oh, and look, I just got a new one. They took their fancy new protractor, if I could get it open here, and they measured out the degrees of each of these. So profits was how much? Profit was 90 degrees. So they put their protractor here, okay, and they marked where the 90 degrees would be. Okay, it would be right here. Now I have got to mark it outside the circle, but then they could connect their dot to their center. Okay, and that's where it lined up. Then they did the taxes, which was only 22%. Now, don't add that to your 90, but just turn your protractor and use your new line that you just drew as your base. And where does 22% go? It goes to like right here, right? Then they drew their line connecting that to the center. Then they did permits. Now, like I said, it doesn't matter what order you go in, but make sure you label each section of your pie, okay? So they did permits next, which was 40 degrees. Well, I'm going to use my new line I just drew as my new base, always putting my center here in the center, lining up my base, okay? And I want 40 degrees. Well, 40 degrees is right here. So now I can put my dot there and draw it down, okay? The next one that they chose to do was materials, 36 degrees. Hey, you can turn your paper around if it makes it easier for you, but I'm going to line up my center in the center, and I'm going to use the newest line that I drew, which was this one, as my base. Okay, not quite lined up. There we go. And I want to go to 36 degrees, which is what, right about here-ish, maybe? Okay, and connect my dot to the center. Now you could start drawing here once you line them up. It doesn't matter. Okay, labor was next at 108 degrees. So center on center, my base line on the newest line that I drew, and I'm going to go to 108 degrees, which is just about here, and draw my line here. Now, like I said, you could just start on the edge of the circle. You don't have to start it out here like I did. It's kind of messy, but it's all right. So then they labeled it labor. That section was our labor, okay? Next was equipment, 65 degrees. Again, center on center, base on the line I just drew, and I'm going to 65. Okay, following the outside to 65 was right about there. All right, and that should line up with the original line that you drew, the original radius. And so that's how a pie chart works. You just draw a radius, and it could be going to the left like this one does. You could go to the right, you could go up, down, it doesn't matter. But when we draw our circle with our compass, we're going to draw in a radius first thing, and then we're just going to tack things on all the way around until we're done. All right, so let's take a look at this on the next page. All right, so lesson 9, the last problem we're going to look at here, page 37. We've got truckloads for the Hackman job, and I kind of drew my line a little hasty there. And then I used my compass to draw the exact same size circle that you have in your book. Most of these will give you the circle, but you know, you can always draw your own because I know you've got your handy dandy compass, right? So I'm going to set this aside for now because we are done with it. And let's take a look at our chart here. We've got all these different numbers of loads of different items: dirt fill, mod stone, 2B stone, dust or stone dust, and for a total of 30 loads. So our first step is to find the percentage of each of these. Let me see now. Is this, can you see? No, we cannot. Let me move it over here. All right, so we need to find our percentage. To do that, we take the number of loads divided by the total number. So 16 divided by 30 equals 0.5333333. So it's 53%. Okay, I moved my decimal 2 places. The 3 is inconsequential when rounding, so it does not count. I don't like that clicky sound it's making. The next part is 10 divided by 30. Well, we should know that 10 divided by 30 was going to be 3.33333, so that is 33%. Okay, for the 2B stone, we've got 3 divided by 30, and that gives us 0.1. Now, when we're working with a number like 0.1 and trying to change it to a decimal, we need to move our decimal point 2 places, or not change it to a decimal, change it from a decimal to a percentage, 2 places, but that leaves a gap, and we fill that gap in with a 0. So 0.1 as a percentage is 10%. All right. And the last one was our 1 truckload of stone dust. And we take 1 divided by 30, and we get our answer as 0.03333. So it is only 3%. If we moved our decimal 2 places, it would be a 3%. Now, they want you to add up your percentages. We've got 53 plus 33 plus 10 plus 3. And that equals 99%. Now, if you get an answer here that is 72%, you've done something wrong. But if you get a 99 or a 98 or 101 or 102, don't worry about that. But anything over like 5-degree difference from 100, you probably got one of these answers incorrect, and you need to go back and check your work. Okay, but this is okay. We're going to work with a 99. Now, though, we need to find out what's the degree. You know, what are the degrees that we're going to use here? So remember, to do that, now we're going to take our percentage times 360. So 53% as a decimal for us to use and in an equation is 0.53 times 360. That tells us that this part of the circle is going to be 190.8. It says 190.8. That 8 is going to bump our 0 up to a 1. 191 degrees. That's going to be a big chunk of our circle, but it should be, right? It's a 16. It's the largest number in our list. Okay, so now for this one, 33%. 33% usable in an equation is going to be written as 0.33 times 360 equals 118.8. Again, this 8 is going to bump the other 8 up to a 9. So this one's 119 degrees. Now let's look here. 10%. Well, 10% of 360, we shouldn't need our calculator for that. But remember, when we had 10%, it was written as 0.1 or you could write it, my kids write it as 0.10, that's fine, times 360 equals 36 degrees. We should know that when we multiply anything by a decimal variation of 10, that we just have to move, we just took the 0 off, right? Our final one is 3%. Make sure you put this one into the calculator carefully because it matters. Remember, 3% is 0.03. We have to leave the tenths space empty, okay? We're going from 3%, we move our decimal 2 places to the left. So we fill in that gap with a 0. So it's 0.03, okay, times 360. And that tells us we have 10.8 or 11 degrees. Now they want us to add up our degrees. So let's take a look at that. We've got 191 plus 119 plus 36 plus 11. 357 degrees. We should expect it to be slightly less than 360 because we only had 99%, right? So this variance is okay. Now that we have all of our numbers together, we can start our circle. So I'm just going to take my compass, or not my compass, my protractor, and draw my radius, okay? So there's the radius that I'm going to use. I chose to go straight down. Like I said, you can put it anywhere. It really doesn't matter. And the first one that I'm going to plot, I like to just start at the top and work my way down. Not sure what was going on with that other one, but that's what I'm going to do. Start at the top and work my way down. So dirt fill is first. I'm going to put the center of my protractor on the radius, or sorry, the center of my circle, and line up my base, my 0, with the line, with the radius that I just drew. And now I'm going to 191. So my base lines up with the outside 0, so I'm going to follow this one around, and my protractor doesn't go far enough, right? Because here's 180, so I'm going to just mark my 180 mark because I need to go another 11 degrees, right? Then I'm going to turn this way, mark my 0 here, line up my base just the same. Okay, center on the center. I've lined up here with my mark with 0, and then I need to go my other 11 degrees. So now here's my good mark. I'm going to erase the 180 degree mark. That's the mark that I want. So lining up I'm just going to use a straight edge here of this protractor, and I'm going to do it inside the circle. So as you can see, it's slightly larger than 180 because it is, right? We have 191. It's going to be more than half, just a bit. And we call this our dirt fill. And we label it with 16 because we're talking about the number of loads. All right. Next here is our modified stone, mod stone, 119 degrees. So getting your protractor back out, you're going to line up your center with your center and your 0 or your base with the line you just drew. Not your original radius, but the line you just drew to do your dirt, okay? And we need 119 degrees. So I'm going to follow my outside 0 all the way around to almost 120, which is 119. I think I got it right. Not being right over the paper makes it hard. But if I was right over the paper, then you couldn't see. So now that's 119 degrees. I want to draw my line to the center of my circle. Make sure your center is clear so you don't miss it or get distracted as to where it is. But I'm going to start it on the inside of the circle like this. Okay, that's my 119 degrees or my mod stone, which had 10 loads. Okay, next is my 2B stone. So again, I'm putting my center on my center. I'm lining up my base or my 0 on the line I just drew to finish off my mod stone. And then I want to go for 36 degrees. Here's 35. 36 is the next little check mark. Then I draw my line to the center. This is my mod stone. Or no, sorry, not my mod stone. I just did that. This is my 2B stone. 2B stone. And it was 3 loads. Okay. And finally was my, and I'm just going to draw an arrow because there's not enough room, but my stone dust at 1 load. Now we could check that to make sure it's correct. We could line up here, remembering that we don't quite, it's probably going to be about 3 degrees bigger than we need because that's what's extra left over in our circle. So if we do look at it, we've got our 0 here lined up, and we look at where the line hits here, it does hit about 14, which is a little bit larger than our stone dust should actually represent, but it's just how the circle graph crumbles, all right? Sometimes it doesn't work out evenly, but it gives us a visual representation as to where our expenses went or how number of loads that we used. And so that's how we plot a circle graph. You guys have done great. Keep up the good work. If you have any questions, you know how to contact me, or you can meet me in my office hours. Otherwise, until next time.